Hello, everyone. I'm Everton de Oliveira. I'm here from the Groundwater project. And today we would like to introduce you to our new release. The book is called Conceptual and Visual Understanding of Hydraulic Head and Groundwater Flow. It's an amazing book. And you see, pay attention to this nice interview. And you see that this book is a book that is missing for so long. I'm, as a hydrogeologist, would have loved to have it as a tool for myself. And you see during the interview, and you have the pleasure to download it because it's for free. And we have today the authors here that are going to talk a little bit about the book. I'd like to introduce you to Dr. Andrew Cohen. He's a consultant in environmental industry and an adjunct professor at the New Jersey Institute of Technology. And also Dr. John Cherry. Among many important things, he co-authored with Alan Fries the Hydrogeology Bible Groundwater and received the Stockholm Water Prize in 2020, the Nobel Prize for Water. Welcome, guys. Please introduce yourselves to our viewers. Tell us a little bit about your hydrogeology passion, please.
Sure, I can start. So I've been in the industry for about 25 years, starting off really on the research side prior to getting involved in environmental consulting. My passion has always been in site characterization and, to put it simply, to figure out what's going on beneath. That's basically what I'm interested in. It's very interesting to try to understand what's going on underground. So that's always been my interest, and I focus on site characterization, fate and transport, evaluation, and of course, I do teach a class. The passion is site characterization, figuring out what's going on, as I like to say. That means incorporating several different disciplines. That's groundwater sampling, geophysics. So what I really enjoy doing and what's of particular interest is data interpretation and really integration of data, recognizing that if we really want to understand what is happening underground, you have to pull in data from multiple disciplines and pull it all and make the story. And also tell the story correctly. And that means you have to present this information in a compelling manner. So that's really what I like to do. The data synthesis, borrowing from different disciplines. I'd say that's it.
Sorry,
John, would you characterize me properly?
Do you have a special passion for hydrogeology, or anything is your passion in hydrogeology? Today, anything, I think.
I took my first groundwater class when I was 18 years old at the University of Saskatchewan, and that introduced me to the topic, and it seemed very interesting, and so groundwater has been my passion ever since. And I went and got degrees, of course, and then became a researcher at a university and whatnot. Research was my passion, but of course, as a professor, you have to do some teaching. So I taught the introductory groundwater class at the University of Manitoba and at the University of Waterloo for 25 years or so. And in the midst of that teaching, early on, I realized we needed a textbook. So Al Fries and I wrote the Fries and Cherry groundwater textbook. And then in a decade or so after that, I realized that students weren't learning very much. Somehow, first you can blame it on the students, but after a few years, you have to blame it on the professors and how we teach and what we have. But I realized back then that to figure out how to teach groundwater better would be a career's objective. So I did very little teaching in the last 30 years of my career. But now I've arrived at an area again where teaching and education is now my main passion with the Groundwater Project. Just figuring out how to help people learn about groundwater, which can appear to be trivial, but in fact is highly complex and needs aids to do that. And that's what this book is all about.
Well, that's very good. Well, the name of the book, Conceptual and Visual Understanding of Hydraulic Head and Groundwater Flow. It looks very big, but what you do is, you try to work the Darcy's Law a lot. So for me, this is an amazing tool. I just loved it. Whose idea was that? Can you tell us how this came to reality?
Sure. I mean, again, I'm just going to kind of speak informally, like we're in a conversation. So we
Please,
can
yes,
make
and
sense.
that's what we're
Right.
here for.
So this started out, John approached me last April, asking if I could help author a book that covers some of the fundamentals. And in doing that, we realized that it's worth focusing on one particular area. It was both of our experiences in teaching hydrogeology that where students really get caught up is actually at the very beginning with the most essential elements, that is measuring water levels and interpolating the data so that you can figure out basically which way the groundwater is flowing. And that's actually the greatest challenge. And the way I like to put it, you know, if you don't know which way the groundwater is flowing, you really don't know anything. It's kind of like if you want to study a river, if you need to know which way it's flowing, that's the most fundamental piece. And also, so if you look at some of the traditional ways in which, now I should say Darcy's law is much more than just looking at the Darcy experiment and talking about the gradient and the flux is proportional to the gradient. Really, yeah. Darcy's law manifests in how in the hydraulic gradient that you observe, in the potentiometric contours that you draw, and really, it's just forms the basis for all of that data interpretation that leads you to understand the groundwater flow direction mainly. So basically, in both of us recognizing that that's where the real challenge is, we decided to just focus on this one topic, because even though it sounds like just a very straightforward, okay, get it over with, show me the equation, it's quite nuanced actually, which makes it kind of fun in a way if you can peel the onion back on something that is usually treated as quite trivial actually. So we called it conceptual and visual because we're not introducing any mathematics at all, except for the simple Darcy equation.
Yeah.
Other than that, there are no calculations or any other mathematical equations presented. Really what we want the learner to be able to look at data, really interpret it correctly, essentially. But also, in order to do that, you need to have basically a conceptual idea as to how groundwater should be expected to flow. And that requires you to really understand what hydraulic head is all about and the distribution of hydraulic head. That's what we're focusing on. It includes much more than just discussing head. It talks about gradients, contour lines, boundary conditions, all of the essential elements in what I think is a compelling and fun way.
When I taught hydrogeology, I would always be amazed at how the students after my lectures and in the exams would display a particular propensity to not be able to convert Darcy's law and hydraulic head into diagrams. And we professors, we usually gloss over that in a lecture or two, like it's just too trivial, so we move on. And we spend a lot of time on equations and all of that stuff. And so Andrew and I got together to narrow the subject, and actually it took us several months to get the subject matter narrowed down to just basically what it is. And I really invite the audience out there to have a look at this book, because I think it'll be the most surprising book that anyone will look at.
Yes.
Given that it delves deeply into something that seems to be so simple. Andrew has a particular talent for drawing figures that are correct and yet simple to look at. And as we worked our way through it, and Andrew would work things up and I would make some comments, we added more and more figures and then little problems. And I think that as a professor, any of you out there across the world, when you get into this, I think you'll look at some of these figures and you'll actually have to ponder them. Some of them, I looked at them and it took me a few minutes to kind of get myself sorted out. Such is the kind of the intellectually intriguing aspect of the most elementary parts of groundwater hydrology. In fact, we're not done. There's more to come. on how we can arrange little figures to see if we really understand. And the problem with conventional textbooks is you can read them and you can do a few problems and you can think you understand it.
Yes.
The beauty, I think, of this book is it continually tests you to see if you actually do. And I think, like Everton mentioned, he enjoyed it, and I certainly enjoy looking at the figures because they're little puzzles. Puzzles in the context of nothing simpler than Darcy's law and hydraulic head.
That's true. That's true. Actually, the book presents Darcy law to exhaustion, right? Upside down, inside out, without actually exhausting the readers or students, right? And I believe that even experienced hydrogeologists might give it a try, like a Sudoku entertainment like tool, right? To test their skills. How is that possible? What do you think about that? Because I think it's fun to try. I tried some of them. They're quite interesting for sure.
So I'm really happy to hear that that was really the intent. And that speaks to the importance of understanding the subtleties that are embedded in Darcy's law. We typically think that it's straightforward to interpret water levels in wells and we draw some contours, but there are some really subtleties that you need to consider if you want to do it right. That's really what this is aimed at. It's aimed at understanding the fundamentals.
So Darcy's law is a little equation, the simplest of all. And hydraulic head is basically an elevation that represents energy per unit weight. But this book takes those two simple things and it converts them to visuals, visuals in 2D, basically. And that's what practicing hydrogeology is all about. You know, once you're done your education, what you have is data staring at you. And the most rudimentary data is head and K. And so when you get out in the real world, your employers or whatever want you to explain the meaning of what head and some K information is trying to tell you. And in many cases, all you have is head, and you're trying to figure out hydraulic conductivity. So I think the point of this is to develop an intuitive feeling by the student as to how to convert information in the form of head and K into a visual expression, into a sketch. So the little figures that Andrew's drawn here are sketches that he's done marvelously in PowerPoint that express things in a relationship visual way correctly. And some of the little puzzles then, you're given just a little bit of head data and maybe a little bit or no K data, and you're asked to give an interpretation. So this book then leads you from the simple stuff, head and K, on into challenging the reader to convert such data into interpretations. Yes. And that's what hydrogeology is all about. And that, in essence, is why the educational student system, in fact, is failing the students. I failed the students when I was attempting to teach. The Freezing Cherry book failed the students because it glossed over this topic in 2 pages or whatever. And that's the way textbooks were back then. You know, the publishers only allowed you 600 or 500 pages. But now with the electronic media, we don't have the excuse then of brevity. So we can work over this topic right down to the last detail. And of course, there's always another diagram that you can add to help the understanding. And Andrew and I now have another dozen or 2 diagrams in our minds that could be added. You know, you could say, how could you add? You've already got 40 on this simple topic. No, we can continue to add.
No, yeah,
it's so much fun.
No, and it is true. I was here. I was here thinking. Sorry for interrupting you guys. I was here thinking because I usually have had problems with people when starting in my company. They go and they have to do the contour of the potential, you know, the potential lines in a field on a map, right? And first thing people want to do is go to Surfer or some software like that that has no idea what goes on with groundwater and the physics of hydrogeology and comes up with a weird map. It has nothing to do with the real world.
Right.
And then the idea is that you have to interpret the potential, the head from between two wells, so you can put the map in your head first, so you can draw the contour. So that's what I see from this book. You can work in several ways before you get to the final map, because you have to understand the flow before you go. Is that the intention?
That's certainly that's correct. And I just want to, when you asked about the simplification or how this is made intuitive, one thing we do is we start out by demystifying this notion of hydraulic head. You look at some of the traditional textbooks and even how it's typically taught, you break it up into pressure and elevation, you talk about density and gravity. And really what we make clear over and over again is really all that matters is the elevation of the water level in the well. And we keep on driving that home and we use that to formulate these problems. And the question is, how do we use that data? Forget about gravity and all that other stuff.
Yeah.
How do we use those water levels? And given certain kinds of scenarios, geologic scenarios that you would encounter, what kind of flow directions would you expect to see? And that will guide the reader how to actually interpret data in the field. As you noted, you cannot simply just triangulate data. You need to have an intuition as to how it should be, and
Yes.
then the data will help you refine that.
Exactly. John, you have something to add about that, because this is quite important. Quite important. People don't see that. They just think that's, you like use a triangle and put the dots there, and that's enough. No.
This book, in a way, is about people having an opportunity to build their hydrogeological IQ. And it's many of us, when we take our first groundwater course, our hydrogeological IQ is very low. I mean, we can be intelligent people, but our hydrogeological IQ is very low.
Yep.
And so it's about basically being able to look at simple numbers, head and K, either one or both, and being able to say something about it, to be able to internalize it and sketch it. In a way, it's about taking information, internalizing it, and sketching it. So the sketches, if we call them that, are very simple. And at the end of the day, we want the reader to take pleasure out of the challenge of sketches, little puzzles converted into sketches. And once we got going on this, it sort of multiplied. We realized there's so many different ways of expressing it. And if you'll note, these figures are very, very carefully designed. Andrew has a particular talent for a design, and every little arrow and every piece of every figure is thought out to the last detail. And so when you look at it, you say, aren't these lovely and simple? Well, they only got lovely and simple by refinement of design. And of course, design people know that simplicity and clarity are basically a form of elegance.
Yeah, exactly. That's the excellence. That's the excellence. When you can get it simple, right? This is so difficult to achieve. Actually, I was thinking, because we just released the book, Groundwater Surface Water Interaction. And for people who read this book first, your book first, the books that we're talking about, the groundwater, it's a long name. Everybody will say about the Darcy's Law book. That's going to be known as, I think, Conceptual and Visual Understanding of Hydraulic Head and Groundwater Flow. If we use this first and go to the other book next, this is going to be another world, because it's going to show you, you're going to understand things just by looking at it. It's so much easier when you have this book in mind. And that is actually, for me, it's a basis. When you go to the field, it happens, it helps a lot that you have your conceptual model done, because you have the feeling. this actually practices your feeling into a great, to a much higher level. That's what I think.
My message to the teachers of the world and the teachers of groundwater, having written the Friesen Cherry text that, was supposed to be so good, and it was a good book, but not for learning. So this book then is for learning, and it's the starting point. In essence, it's the starting point. And I think the challenge that professors are going to have is how much of this do they want to try and teach from the book, or are they going to say to their students, study this book for 2 weeks, study it for 2 weeks, and then we'll get the class going. In a way, you can just sit and study it and practice. And if you understand all the diagrams, if you understand them and can reproduce them, then you're ready to take a class. And as I mentioned, was always amazed when I was teaching how when I'd move on to things that are more complicated, how basically I would lose the students. There was something lost there. And I didn't know didn't know how to fix it. I lived with it, and now we have, I believe, a fix.
No, I think so. Actually, this is a very good example of what the groundwater project came in for, right? Because we have this very first great example. What do we have, right? On a single subject that explains everything. I had an example when I was studying to get into university. I had this very old professor. He was a mathematician, and he has this great book for high school. And he was a self-taught person. He never went to school at all. Wow. And he was amazing, so good. And usually in his classes, I always remember, because he used to go there, and he used to explain things in 10 minutes. And he goes, it was very, the essence of things. And then he gives you some exercise. And the class was always in a huge silence. Everybody was working, having fun. And I say, how can he do that, right? And also that's exactly what we see. You have a book there, and you have the examples, and you can do it on your own. You don't have to read much, because you have the simple message up there, and then you go and do it. So what do you expect, or how and when you expect people should use that? And at what time? Later in their career, early at school, or any time? What do you think?
So this is a book that I think people should look at from the very beginning, because it really just lays down the fundamentals.
Yep.
And one thing that I think will be very helpful, there are some example problems that the student can do, and we do provide answers. But in addition to providing the correct answer, we explain why the incorrect answers are incorrect from a conceptual perspective. So the student might be presented with a multiple choice problem. You're then provided with the answer, but also the incorrect answers are explained. And that provides, I think, a deeper understanding of the essential elements, or it provides a deeper understanding. So there's a lot of learning much can be learned by understanding why an answer is not correct.
Exactly. Actually, we learn more when we don't do well on the exam, right? Then you have to redo everything. Then you do learn it. That's the idea. So you get the wrong answer and go through it. Actually, just to make sure we don't have only answers, we have solutions in the book, right? We have a whole solution. Explaining.
That's right.
Yeah.
That's right. Explanatory solution.
Exactly. Very good. Very good.
I think that one of the challenges then for professors when they use this chapter, it's set up for the student to work the way through it, looking at the problems and then trying to do them and then seeing if they got them right. And then I think the challenge to professors then will be within this theme to make up new problems for which there aren't answers. So what can professors add add to the game? Well, they need to make up new problems. And those are challenging. And even the students should be expected to make up new versions of these problems and provide solutions to them. It's like basically a jigsaw puzzle, you know, and a manufacturer makes one, and then you can make others and go on forever. And it should be great fun.
May I ask you something? What if people suggest new problems for you? Would you be able to incorporate into new editions of your book? What do you think?
Well, you can edit this however you want, but one thing, certainly so the idea is there, as John said, many different kinds of problems can be formulated that would be useful for students, that requires them to think in kind of a conceptual manner or on a deeper level. So I'm confident that there are professors around the world who have, at least to some extent, formulated problems like these in their courses. So those can be great contributions, something that can be put on the website, or who knows, maybe there is a second edition with some additional materials. I already have something in mind. There's a supplemental piece to understanding head and understanding the expected kind of directions and contour lines, and that is, what are some of the nuances associated with data interpretation in the real world? And that area, that data interpretation, the development of contour lines, which are then used to identify groundwater flow directions. That is something that everyone can benefit in refining their skills, because that most fundamental information can lead people down a rocky road of making wrong decisions regarding remediation or groundwater exploration or management or identification of aquifers that are sustainable and so forth. Really, it's the basis. It's essentially, like I said, you don't know anything if you don't know the direction of groundwater flow.
Exactly.
So yeah.
Yeah, that's true. John, you want to add something?
Well, the number of possibilities for little sketch diagrams is huge. And Andrew recently ran across an example on the web of a figure where the question is, what's wrong with this figure? And it's just a little head type Darcy question. And one could produce dozens of those, almost as universities love to have true or false or whatever. So it lends itself then to all sorts of ways of testing one's knowledge. Very straightforward. Okay, what's the answer? Can you prove true or false, or one word, or whatever? Is it right or wrong? So I think we've opened up here a methodology. And as Andrew was saying, that people from all over the world hopefully will contribute their contributions to it. And this could be one of the many wonderful new avenues that the Groundwater Project is setting loose. And when Andrew and I started this venture, we really no idea that we were going to, first of all, narrow it so narrow, just Darcy's Law and head. And we had no idea then, in fact, as we had to say, stop, is it figure 42, Andrew? Every day or two, we're figuring another figure. Okay, well, it had to be stopped because we have to get it published. So we've unleashed something, I think, that's creative and exciting and educational, and hopefully we'll just see it bloom.
Yeah, yes. It was hard. It was hard to stop creating all those more figures and example problems that provide some additional insight.
But they're very good. Well, apart from Darcy's Law, because this book is all about that. Are there more fine cookies coming from this oven? You have more ideas that we can expect? Are you working on something else, you two guys?
Well, one thing I just want to clarify, because we talk about this being about Darcy's Law, and I think when people hear that, they do think about the simple, cylinder with a head differential, and that's the end of that. But what we've done is we've recognized that that's also manifested in how we look at contour lines, how hydraulic gradients are result from various configurations of hydraulic conductivity distributions. One thing that we point out, I think, is that's really important. There's a notion that hydraulic gradient drives flow. And that's something you hear a lot. But I think one thing we try to do is show that hydraulic gradient and the orientations, the resulting orientations of flow are really a manifestation of the distribution of hydraulic conductivity and your boundary conditions. That is, where are you in relationship to recharge boundaries, discharge boundaries, low permeability layers. So that, I think that provides a different perspective that I think will be very informative to people.
I agree. For me, I have this picture when we're working with conceptual model, because we're always refining a conceptual model, right? And for me, this book, working with Head and K, basically, which is Darcy Law, these are the chisels that we can refine your work of art, right? The best you work with these tools, the best your work of art will be. Your conceptual model would be much more, representative of the reality if you can work best with these tools. And I'm totally with you in that people don't give enough attention to that, to understand that this is all that is to understand groundwater flow properly, which is not trivial in the real world. It's quite difficult, right?
So in this context, Everton, this is very interesting. I suppose another title could have been, conceptual models from nothing more than Darcy's Law and Head. Because all those little sketches are just a conceptual model. Yeah.
They're for that.
And maybe when this chapter gets revised, maybe we start off using that term more. And as Andrew pointed out, the chapter actually leads you to understanding what a flow system looks like.
Yep.
What boundary conditions are. Like, it sets you up for all sorts of other chapters to come.
Exactly. This is I told you I loved it. That's very good. Well, we still have time to change the title if you want. It's not released yet. We can restart the interview with a new title.
Sure. No, the title might be long, but I think it is.
No, leave it like that.
I know.
Joking. I'm just joking.
Just as an aside, it is interesting that we're not talking necessarily about subtleties in how you interpret data. What we show, or what the reality is that depending upon how you look at the data, that is how one interprets water levels, you could come up with very different flow scenarios. You might think it's a subtle difference, but we're talking about left, right, up, or down. I mean, it can be actually quite profound. It's quite interesting.
That's true. You like preparing these nice illustrations for groundwater education. Do you have any ideas on how to engage more people like you into the groundwater project to bring in more help? Any brainstorming is welcome here, please.
Well, let's see, brainstorming. Right, so you're correct. I do enjoy developing these figures. And in fact, one possibility is reaching out to other, I'd say, earth scientists, geoscientists who have a proclivity for drawing these or making these illustrations. And I can tell you that the people who make the good illustrations really do, it provides a lot of satisfaction for them. So I think they'd be eager to help. I've already reached out to someone else that I know is really quite talented in this area. And she indicated that she would be interested in something like this. So maybe there's an opportunity to develop a community on the web. I thought about that, creating kind of an interactive web group discussing figures. And actually something that I also had in mind is, so John and I talk about this, it's really a clear illustration, it's so key to the learning process.
Oh, yes.
And there are many different ways you'll see in the literature, on the internet, just even simple cross sections, how they're presented. So one thing I was thinking is actually to pull together a collection of figures from the literature of the same kind of drawing, and to distribute that or have some kind of polling to find out which figure is most compelling to students. There's some element to figures that hits home or really conveys a message. It's different, maybe it's a little bit different for different people, but I do believe that there's some commonalities. It'd be interesting to actually find out what those are. And I think something like the Groundwater Project, some kind of polling mechanism would be interesting.
That's a good idea. That's a good idea. We can I think we could shore up this idea and see how we can develop. We have a marketing team, as you know, they have lots of great ideas on how to engage people and checking things. So that's I like that idea. Let's see if we can put that into practice. Let's work.
I could ask Andrew a question. These beautiful figures, at the end of the day, are beautiful because of their accuracy of thinking and simplicity and elegance. So Andrew, like, how long would it take you to do one of those figures? In hours? You probably don't want to think about it because it took so long.
Well, I think part of the length came from all of the adjustments to the actual document, what material we decided on covering. But I can tell you that the figures themselves took minutes really to draw, to sketch out on, architecturally. It was the migrating that over to something like, I wound up using PowerPoint, might not be the most effective way, but I know a lot of tips and tricks and things like that. And it's a problem when you really like precision and you like things that are beautiful, you can wind up spending a lot of time on the simplest figure. And so you can kind of get addicted to it, and I sometimes need to step back because there's always room for improvement. And you draft it one time, and 2 weeks later you look at it and you see that the water level symbol is a micron off of the water surface. So you spend a half an hour fixing that, things like this. But I actually, John, I think that's important for people to know that simple figures, or you might call them that they're very compelling, they're elegant. It doesn't mean that they need to take a long time. It's really these kind of sketches, they're just formalized in this book, but they're just neat. They're neater, publishable representations of something just drawn with a pencil on graph paper, or not even graph paper. And I think that's something that the student might keep in mind, is that these are problems that you really could sketch very quickly. And in fact, it would be nice, maybe one goal is for the people that are learning or trying to understand this, is to get to a place where if you posed a problem to them, they would be able to sketch it out. And that's where that conceptual, that coupled conceptual and visual understanding comes into play. It's like, okay, can I conceptualize what the issue is, and then can I imagine what it looks like? Can I imagine what the corresponding shape of the contour lines need to look like, and be able to sketch it? That's really the foundation of every project I've ever worked on.
Late in my teaching career, before I gave up, I got to the point of having many exam questions where the question was a paragraph. Imagine a situation where you have 2 layers and a bunch of wells, and here are the head numbers. And then I would ask the students to express that in a carefully labeled sketch figure. And what I found, disappointingly in many cases, is that no, they would give me a paragraph back, or they would scratch something off that I couldn't understand. And then eventually, in order to force them to sketch, I would say no marks are given for words or equations. And that caused great psychological strain and terror, I think, because it's not taught. It's the essence of hydrogeology, and it's not taught.
Well, we're coming up with making the final sketch or a final drawing is not all the point. The point is having the clear situation in mind, right?
Oh,
Then
yeah.
you can put into the paper what you're thinking. If you don't think properly,
Yep.
the sketch will never be good, right? Because it has to be clear on your mind.
Yep.
So when you know a lot about the groundwater, you can make some good drawings because you have it in your head. This is not easy.
No,
It's not
that's
easy.
the goal. That's the goal of this book. Yep.
Yeah. Guys,
Yep.
our talk is very good here, but we need to get to an end. Please, would you make your final statements for those who are still in doubt if they should download this book, please? Anyone?
Sure.
Andrew first.
Sure. Okay. So I think the reader will, well, the first part is that it's free to use. And you'll find, I think, that it's quite fun, in fact.
This book is a starting point for learning about groundwater science. You cannot start from a more basic level than this, and it works your way up to quite an advanced level of thinking by looking at pictures, by doing the problems, and by pondering. So of all the books in the Groundwater Project, if you want to start learning groundwater, this is the one. And it could be done in high school. It's a book for anyone. You just have to know what head is and Darcy's Law. And then you can start to actually learn about groundwater.
Perfect. I can tell you, I could do the exercise, so anyone can do it. It's this simple.
Well, I can tell you that I've come across a couple of very experienced hydrogeologists that got stumped on some of the most fundamental questions. And it just goes to show you that, I mean, certainly these people are skilled and they know what they're doing, but there are little subtleties that are very important and can be misunderstood. And I would just second John's point about the pondering part of this. That's something that we had in mind in developing this book. We want the reader to go through to learn, but at each we continue to reiterate concepts and make reference to figures and things that were spoken about in previous sections of the book. And also we continue to ask the reader to ponder a problem. So a particular example problem really requires the reader to think about it for a while. It's not it might get to the point where they can answer it easily, but they really need to ponder it. That's one of the aspects of hydrogeology that I think is most satisfying, is to ponder what's going on and try to figure it out. So that's the most fun.
All right. That was a pleasure talking to you guys. And I do believe this book is going to be a great success because it's very nice, it's well done, and is actually very needed for people who wants to study groundwater. Thank you very much.
Well,
And success on your book. Yes, John.
I've got one more comment.
Yes, please. You're welcome.
This book then is the first step in learning about data interpretation.
Yeah.
So the equations have been given, everything's been given, and you're given information. The information is data. So it's the starting point for learning about what data interpretation in hydrogeology is all about.
Yes, that's true.
Yeah.
It's very true.
I'm
Yes,
really glad you said that.